Welcome to today's paper reading. Today's paper is titled, From Rags to Rich Parameters, Probing How Language Models Utilize External Knowledge over Parametric Information for Factual Queries. This paper was published on the AR14 preprint by Hitesh Wadhwa and colleagues from the University of Massachusetts, Amherst, Microsoft, and the University of Maryland, College Park. Retrieval Augmented Generation, RAG, enhances language models by incorporating external context to improve responses to user prompts. This method is widely used in applications like search, question answering, and chatbots. However, the internal workings of RAG are not well understood. In this paper, the authors investigate the RAG pipeline to reveal that language models often take shortcuts and heavily rely on context information while minimally using their internal memory. To explore this, the authors employ causal mediation analysis to demonstrate the minimal use of parametric memory, and use attention contributions and knockouts to show that the last token's residual stream is not enriched by the subject token in the question but by other informative tokens in the context. This shortcut behavior is observed across both Llama and Phi models. The increasing use of language models, LMs, in industrial applications has led to the popularity of Retrieval Augmented Generation (RAG). RAG provides additional context for effective reasoning, helping to mitigate hallucinations. However, the comparative usefulness of RAG versus model priors remains underexplored. Meanwhile, knowledge localization and editing techniques in LMs, such as ROM and MIMIT, focus on adjusting internal parameters to update or correct knowledge. This paper aims to analyze how RAG context influences LM predictions over prior knowledge, understanding the interplay between LM's prior knowledge and external information retrieved during inference to prevent drift in model reasoning. Figure 1 illustrates the setup of a factual question answering (QA) system enhanced by Retrieval Augmented Generation (RAG). This setup is employed in the study to evaluate the effectiveness of parametric knowledge stored in language models like Llama and Phi. The figure highlights the integration of RAG to augment the QA system, providing additional context to improve the accuracy and reliability of responses. By comparing the performance of Llama and Phi models within this RAG framework, the study aims to understand how these models utilize both internal parametric knowledge and external retrieved information to answer factual queries. RAG systems have gained popularity in natural language processing due to their ability to significantly enhance the performance of language models by integrating external context. However, these systems are not without challenges. They can sometimes generate inconsistent predictions, even with perfect retrieval results. Research has explored ways to reduce hallucinations and enhance accuracy in models like GPT-4 by leveraging external retrieval systems. Despite extensive use and documentation of their shortcomings, there is a gap in understanding the balance between a model's internal knowledge and externally retrieved information. Specifically, a systematic exploration of a model's preference for RAG-provided information over its parametric knowledge has not been conducted. Our study aims to mechanistically probe into these internal workings, particularly how models exhibit a shortcut mechanism when provided with non-parametric knowledge via a RAG system. To understand the mechanisms contributing to factual reasoning in language models, the authors employ three probing methods. The first method is causal tracing, which identifies specific hidden states that significantly influence factual predictions. This involves three runs: a clean run, a corrupted run, and a corrupted with restoration run. The indirect effect, i.e., an average indirect effect AIE, are used to quantify the importance of these hidden states. The second method is attention knockout, which focuses on the role of attention mechanisms in shaping model output. By examining the norm of attention weights, particularly from the subject token to the last token position, the authors identify critical attention edges. The third method is attention contribution, which investigates how attention weights contribute to model predictions. This method involves setting attention weights to negative infinity to block information flow and assess the impact on prediction quality. In this study, two state-of-the-art language models are utilized: Phi 2, 2.7b, and Llama 2, 7b. These models, trained on different corpora, allow for a comprehensive investigation into the influence of Retrieval Augmented Generation, RAG, on factual queries. The analysis is conducted using the Knowns Fact dataset, which contains 1209 factual queries in the SRO format. Synthetic RAG contexts are generated for these queries using GPT-4 to control variables such as segment length and attribute presence. Empirical results indicate a significant decrease in the usage of multilayer perceptrons, MLPs, and an average indirect effect AIE reduction when RAG context is present, compared to the vanilla setting. Figure 2 illustrates the minimal reliance of language models on MLP parametric memory when retrieved context is present. The figure shows the average indirect effect AIE from MLPs after corrupting the subject and context for RAG scenarios, and only the subject for vanilla cases. Key notations include FST, first subject token, MST, middle subject tokens, LST, last subject token, FSSD, first subsequent token, FT, further tokens, and LT, last token. A significant observation is the five-fold decrease in AIE for LST with RAG compared to vanilla, indicating a reduced usage of MLPs when RAG context is available. In the first finding, the average indirect effect AIE of MLPs representing subject tokens significantly decreases in the presence of RAG context. Specifically, the AIE drops from 0.2 to 0.0375, indicating that subject tokens within the query do not activate parametric memory when context is present. This contrasts with the non-RAG, vanilla case where subject tokens have a high AIE and are crucial for factual retrieval. The second finding focuses on the last token residual stream. Analysis shows that 70% of the layers contribute nothing to the final token prediction. Attention contributions from the subject token to the last token decrease in RAG scenarios, suggesting a larger influence of RAG context in fact prediction. Additionally, attribute tokens have a more significant impact on fact predictions compared to subject tokens. The main takeaway is that in the presence of retrieved RAG context, language models primarily rely on the context and minimally use parametric memory to answer questions. The last token residual stream largely ignores information from the subject token position in the query, emphasizing the importance of context over parametric memory. Figure 3 illustrates the impact of retrieved context on the enrichment of information in the last token residual stream. Panels A and C show that the contribution of the subject token, ST, is significantly lower in the presence of RAG context compared to the vanilla setting for both Llama 2 and Phi 2 models. Panels B and D highlight that the attention contribution of the attribute token, AT, is 5 times higher than that of the ST in the RAG context. These findings suggest that the RAG context has a substantial influence on the information flow within the models, reducing reliance on the ST and increasing the importance of AT. Figure 4 illustrates the minimal effect of knocking out attention weights from the subject token in the query to the last token when retrieved context is present. On the left, Llama 2 shows a 20% decrease in probability when attribute tokens are knocked out, while on the right, Phi 2 experiences a 25% decrease. Interestingly, knocking out the subject token attention results in only a 5% probability reduction in both models. This paper represents the first study to employ 3 distinct mechanistic probing methods to understand the advantages of using RAG context as an external knowledge source. This complements the parametric knowledge stored in the models for factual queries. The study delves into the utility of parametric memory and the interaction between parametric and non-parametric memory in retrieval augmented generation. It is observed that parametric memory becomes less crucial for factual recall when RAG context is added to the prompt. Through analysis of attention contributions, attention knockouts, and causal traces, a reduced dependence on the subject token and associated MLP activations is specifically noted when the context is enhanced with RAG. The current study has limitations due to the use of short RAG-based context. Analyzing longer contexts currently incurs a significant computational overhead. In future work, the authors plan to investigate the impact of long contexts and the effects of subject and attribute tokens, particularly their positions and the tendency to exhibit proximity and recency bias. Additionally, The study did not cover instruction-tuned models or models fine-tuned with objectives like RLHF. These will be topics for future research. The current study was conducted in a controlled setting with synthetically generated and well-formed contexts, which does not reflect the noisy and retriever-sensitive nature of practical applications. Examining these practical aspects is also planned for future work. Thank you for watching.